Yeah, hello everybody. I hope that you have enough coffee. I hadn't one, so I picked mine later, so it's no problem. I had enough in front of it. Yeah, we're talking about yachts and how you can have access for them and why also this topic. Yeah, it's an interesting story. So we have a little bit of an introduction, then some kind of a maritime one by one that you have a briefly understanding about some techniques behind it. Then we dive deeper into how we get remote access to those yachts because of I found some router or Satcom vulnerabilities that we can use for that. And at the end, yeah, some forecast about what's going on, and that's it. So I'm only covering topics on yachts because it's a different area than normal merchandise ships and so on. So they are not relying under regulations like SOLAS or something like that, as commercial ships have. So private yachts are a different story for that. But they're using the same techniques. Yeah, a little bit over me. So I'm older than the internet. You can then know what it is. I'm certified a little bit electronic specialist. I was working in the German army, so for repairing navigation system for helicopters. So that's one of the backgrounds that I had for those topics that I have here. I'm now more than 31 years a volunteer firefighter in Germany, so that's my passion since decades, and I like it. And in my company, I'm working as a security evangelist. I pray all the day about security. Sometimes they accept it, sometimes not, but they're doing good. And also pushing a little bit our new branch of or spin-off of our company, the certification. So we're doing some certification and auditing stuff and pen testing and so on. And yeah, of course, I'm void warranties, so I always want to know how things working. So I buy stuff, I open it, and then take a deeper ground to look inside. Okay, they have done it like this. The same techniques I'm using also. Why are parts broken for my car or for my motorcycle? Because mostly it's small pieces that are broken, and why I have to replace all the things when only a small piece is broken. So then I'm volunteer also I'm the cavalry group, and with my German or let's say European friends, the Geraffel group. That should be enough about that. So what were in the newspaper the last month? So you cannot really read it very good. So but these are a couple of news articles about hacking yachts and stories behind it. So hacker carping yachts, how hackers are targeting the shipping industry, cybercrime on high sea, and so on. So, and the other thing was last year the US Navy had 4 accidents with their naval ships. So they came rumors up, they may be hacked or not. So these are quite interesting stories about that. So, for example, for the USS Fitzgerald, there is a completely report. You can search for it and download it. And the conclusion of that report was that it was a normal navigation failure about a human error. So they followed not the guideline with 2 people on a bridge and were sleeping too much, and also the container vessel that is crashed into the warship was running on the autopilot. So, but we will look at it later. So, what's about vessels and yachts? The yacht, it's a recreational boat or a ship. And the term comes from the Dutch word from hunting. So hunting in Dutch means yacht. And the yacht word is a little bit similar to the yacht word that we have now in the English. So normally it was fast vessels for hunting pirates in the in the sea of the Dutch countries, and therefrom the term is coming from. And of course, size matters. So if you have only a boat, it's up to 7 meters. When we're talking about a yacht, we have 10 meters or bigger. Super yachts about 24 meters or up. And if you have enough money, then you have a mega yacht, 50 meters or longer. I think there was a mega yacht now burning down in the Lürsen shipyard in Germany in a fire. So it was in the construction time. Should be finished in 2 years, but it's now burned down completely. It was 176 meters, I think. So did not finished. Okay, this is one kind of an example what I follow on. This is one of a German TV show celebrities. They have a super yacht called Indigo Star. This is a picture of that. It's built 1996, so we will see it later, and I use it just for an example. So I sometimes telling that yachts are swimming IoT. So why it is swimming IoT? Because we have so many systems on board. So like vessel traffic services, automatic information identification systems called AIS, the autopilot, the GPS, radar, CCTV, thermal imaging cameras, and so on and so on. So, and of course, internet access for exchanging data. So this is then how it looks like on a ship or a yacht. So here we have a bus system that's going completely through the ship, and on the bus system are the different devices connected. So we have a speed transducer, we have a deep transducer, so it's some kind of sonar to measure the deep underground. Battery system is also connected there, and we have here a gateway system, because in the NMEA is a short term for National Marine Electronic Association. So, and they standardizing the messages that going over these networks. So this one is an older system. It's the NMEA 0183, and it's a serial bus controller. So all the messages going here over is a serial protocol, so you can easily tap it. So this one is already an NMEA 2000, and it's a CAN bus. So it's a traditional CAN bus, but they have different regulations about that. And here we have also a compass, we have displays, we have here laptops with a gateway to the CAN bus. The radar system, GPS receivers, wind transducers, everything is connected to the bus, and all the informations are shared together. So this is how the cables are looking. So just like in the older days, the cheaper net. So you have T connectors to connect it to your device. Yeah, as already said, you have the different devices that are connected to that, and just over serial speed. So the newer version, it's the CAN bus, and you have also gateways for those systems. So this is now from one of the vendor websites, and they have here connected everything to one system together. So here we have the GPS receiver, and it's connected to the bus system here. Then we have here the yellow one. This part is completely for autopiloting. So here's a remote handheld for autopilot. We see it later. Then some devices for the handheld, and here's also one device for the autopilot system. Then here we have the other things that gives you a status about the RPM of the engine, the speed, the course over ground, and so on. And here is an nav computer for that. And there are also some other devices. But this is a nice overview about how the system is working, and everything is connected together. So most of the system that they are using is some kind of the vessel traffic services. It's like air traffic services, but for ships then. And then we have the automatic identification system. So we hear about later. And one of the major things is the ACTIS, the Electronic Chart Display and Information System. It's like a digital navigation card, like you had in the older days a paper chart about for navigating. Now you have it in electronic format. And autopilot systems also, and we have some kind of internet access. So, as mentioned before, the vessel traffic services, it's a complete independent system that's using radar, AIS, CCTV, and a VHF communication to transmit the information about. So, the VHF signals that you transmit there, it's a nice topic where you can research a little bit more. So I've not started yet in that area, and I only have seen one or two about they doing investigations in the vessel traffic services. And yeah, so this is about that. So the AIS is more or less some kind of a system where you have an positioning services and it using GPS informations. So the GPS receiver sending the signals on the CAN bus, and all devices are using these GPS informations and working with that. So the AIS services is also using the GPS information. So that you have to keep in mind. Okay, it shows then on the map information about the ship name, the call sign number, additional information about the systems and so on. And AIS is normally a VHF system, or you can have it also as a satellite transponder system. So it is used as complementary navigation tool like GPS in aircrafts. Yeah. So this is now then the ACTIS, the electronic chart display. So here we have the sea chart, and the position of the ship is then displayed here in the sea chart, and the position is get from the GPS system, and also the information from the AIS are also displayed here in this device. So the ACTIS combining already the AIS information and the GPS information. Yeah. And the last part that we have then is the IT equipment that we have on board. So we need some kind of internet access via GSM, Wi-Fi or SAT. And we have some kind of entertainment systems, Wi-Fi, voice over IP for telephone, and so on. So how it looks like. This is from a picture from a 40-meter yacht, a complete 90-inch rack full of equipment. So we have here the internet router. We have here a server, 3 servers by the way, 2 voice over IP gateways, a fully equipped switch, and uninterrupted power supply. And that's the other stuff that is on these 40-meter yacht. So 10 smart TVs, a Sharp PC, 14 voice over IP telephones, internet routers, and so on, and 4 Wi-Fi access points. I know from a 70-meter yacht, they have already 26 access points for Wi-Fi coverage. So the bigger the ship is coming, the more stuff you have on board. And because it's a nice play toy, most of the systems on board you can control by mobile devices. So you have tablets to control the curtain or the light system on the ship. You can make switch on the underwater light when you're laying in a harbor and so on. So everything is controlled with a tablet or with your mobile phone. So you push the button. So it's some kind of a smart home system also. And I have it not in my presentation here, but I give you an example later. So now we have seen so many systems, and this is then the kind of attack vectors we have there. So we can attack the systems over the internet because they are online. Or when we don't find any vulnerabilities there, so maybe we try to spoof some informations or send scam messages, scam mails, or phishing emails, and so on, and try to infect the computers about that. Or we try to attack the mobile devices of the crew, of the captain, or of the passenger on board. And when we have gain access anywhere there, so we have to search for the gateways that connecting the computer network to the CAN bus system. And there all the other devices are connected. And by the way, most of the gateways are bidirectional. So you can not only receive information from this NMEA network to the TCP/IP network, but you can also send messages from the IP network to the CAN bus. Okay. The attack vectors were GPS, AIS, autopilot, IT equipment on board, the internet connections, cloud-based services, or the crew's personal electronic devices. So let's looking a little bit deeper how some kind of those attacks working. So GPS, or global navigation satellite services, as they normally named, but GPS is more familiar. You can, we have 4 different versions about that. So the GPS that most of the people are using is the US-based Navstar. Then we have a Russian version called GLONASS, Galileo from the European Union, and the Chinese have their own system called Baidu. And these are the frequencies where they are working on. So they are only using 3 bands. The L2 band is more for military use and encrypted. L5 is not really used, so most of the things are working in the L1 band. So as you can see already, then all the systems are working in this area, and there's only a couple of frequencies where you have to deal with. So the possibilities that you can do now here is we can jam the signals and we can spoof it. So jamming is quite simple. Just scream out some noisy signals on the same frequency and the GPS receiver is not working. Spoofing is a little bit more complex. So you have to inject all the right information about that the receiver is then accepting those messages. But there is special hardware for that. For spoofing, you can buy some kind of these GNSS simulators, and with the right antennas, and when you are in the right area, then you can play with faked GPS signals. But you only should do it in lab environments. You can buy them. I don't know how much they cost. I think around about 1,000 euro and up. But yeah. But there are other topics that you can use. When you have physical access to the NMEA network, there are software solutions that you can use, like this one from Atlas Soft. So there's a GPS simulator software that can play, also you can play some GPS coordinates into the network, or you can record those messages. So it's useful for when you simulate some checks or when you try to calibrate your navigation systems. Therefore you need it. And you can use it also for other things. So when you have a small computer, battery powered or however, and connected to the network, and then it's injecting some messages at a certain time, I don't know what then happens. Jamming is happening quite often, mostly during big maneuvers of the military. Then they disturbing often the GPS signals. How you can detect some kind of those jamming or disturbs. So, or there is also a research project from the DLR called Galant. So they have an antenna area. So this small device here, and it's in 2x2 antenna area. And because they have 4 antennas now, they can see from which direction the antenna signal or the GPS signal is coming, and then calculating about through that, is it a valid GPS signal or not? So it's working good, but it's still under the testing phase. I think it's maybe coming next year. Yeah. AIS already mentioned. In the automatic identification system, we have a bunch of information that are transmitted. The needed ones are I'm under anchor, underway, not under command, and so on. So some kind of status messages. And the mobile subscriber or service identifier. With that, you always can find the ship. And you have additional information like speed over ground and so on. This is then how it looks like. There are special web pages for that where you can search for that. And then you have, by the way, it's the same ship as in the first picture. So it is moored. You have here the building year of the ship, the length and the beam. It's running under this flag, the calling sign, the EMO and the MMSE numbers and so on, and the tonnage of the ship, and also when the last time the position was received and the speed and the course of that. So all these information you can see all the time online. When a ship has an AIS transmitter or transponder, then it has to be switched on all the time. So that's one of the regulations about that. How to deal with that is you can receive your own messages. Just take an, let's say, HackRF and build your own receiver for that, because it's just small, an easy thing. It's a VHF channel where you can use it and so on. And someone did already the work. There is a GNU radio chart for that. So you can download this chart, put it on your HackRF, and then you can receive the AIS information about that. When you change the chart a little bit, you can also send messages, but that's also not allowed. But sometimes people do it. In maneuvers, I have seen already that some militaries playing also with that to simulate additional warships for the maneuver. But yeah, they didn't. They shouldn't. Okay, autopilot. I mentioned it in the front. So autopilot, we have seen that there was a remote handheld, some kind of radio transmitter where you can change the speed and the course of the ship. So the receiver is somewhere under the deck, and this is one of those handhelds. This is only a sample from that. Yeah, and I had only a picture, and a sailor friend of me, he said unto me, hey, this is an autopilot with a remote handheld. So, okay, sounds interesting. So, yeah, I looked up what it is. In this case, it was a Raymarine S100 wireless remote controller. So FCC ID'd it, and then I found out what it is. And it's working on 2.45 gigahertz, and it's not Wi-Fi. So on the FCC ID website, you find information about how the electronic is built up. So it's an easy RF transceiver, and it's an Atmega microprocessor. And the protocol that are running is some kind of, they call it Ember stack, because it's from Ember Wireless. I have no idea what they're transmitting because I have no samples. So next time when I have an yacht in my area where I can work on, I will record some of the samples and then I can deal with it. And yeah. Okay, now we come to the funny part.
Rabbit is in the administration system. Send a blue shot.
Rabbit, blue shot, someone talk to me.
A rabbit replicates till it overloads a file that it spreads like cancer.
Cancer? Mr. Gibson, it's finding us too fast.
Okay, so a nice video clip about from the movie Hacker. They already 1996 they were playing with attack scenarios like this. Some of them are possible now, not everything was shown there, but yeah. Okay, why attacking yachts? Because of most of the CEOs owning one and running their business from a yacht. So if you have access to a yacht or the network of a yacht, you maybe gain information, private information about how they build up the business in the next 5 months or 6 months or whatever. And think about celebrities, they owning their yacht or renting a yacht and laying in a harbor, and yeah, when you need some pictures from them, why make pictures with a camera? Just take the devices on board. So it's a different thing. So these are most of the things why attacking yachts. So, but I did not heard about a real attack now. Maybe it comes more and more. But how we can access them now remotely? So we need to find a way how to get on board electronically. So that's what I found out because I was working on a yacht 2 years ago. And found out that one of a yacht router had some vulnerabilities. So in this case, it was an yacht router from Loco Marine. Loco is a Spanish word for mad. I don't know if it is an coincidence in that case, but yeah, they have a Wi-Fi booster module. So they have 15 nautical miles Wi-Fi range and also up to 30 nautical miles for 4G, 3G or 2G communications. And they're working really like this. This is the software they're using, so the control software for that. You have a version for a PC and for the handheld for your mobile phone or for your tablets and so on. So what I found out then was the software doing some kind of FTP connect. Every time you starting the software, it makes an FTP connect to the router. So I say, what? Okay. Yeah, then they downloaded an XML file from the router and stored it in this application. And every time when you change something in the application, it modifies the XML files and make an upload again to the router. And yeah. And as you know, FTP is clear text. And they're using hard-coded credentials. Why? I don't know. The XML files also including other juicy informations. So when you looked up the traffic, you see the username in this case is also Loco, because of Loco Marine, I don't know. And the password was quite funny, secure connecting user. So, and when you, okay, after I found out this, then I take the application on my computer and looked up, okay, it was a .NET application in C#, I think. And then, okay, I'm using tools like ILSpy, loaded the software in it and looked up what kind of information I could find also. So they have some kind of juicy information here. You cannot really read it here. They're saying a username called Franjo, and then we have here a username John and Jere, and also other additional things. And in one of those engines, by the way, this is yacht router engine mentioned. Here you have the complete configuration about the username, the password, the FTP URL, and also the Wi-Fi configuration about the router. So that's in the software. You can easily look up. You can download the software from the web page without any authentication or so. So just go there, download, and take a look. Then the vendor think, okay, a firewall we don't need. We connect to the internet, so we are on a high sea. What should happen? There is no firewall, and all those ports are open. 21, 22, 53. They're using SSH, but for the configuration they're using FTP. Why? I don't know. And when you look here, this is already the patched version, and it's a 6.36.4 MikroTik router. So that's the back end working on there. So when you follow the news, you will recognize that this version is also vulnerable for another attack. But this is the patched version that they have out there. Okay, then they have some kind of remote support. The remote support is doing some, you call the vendor, you're saying you have a problem, and you give only the serial number to them, no IP address. Okay, how do they know my IP address when I'm online? They're doing a ping back. So every time when the system is connected online, they're pinging back to their own network, and then they know, okay, this device is online, this is the IP, and it has this serial number and so on. As we remember from the remote support, they're using a MikroTik router, and the MikroTik routers have some these Winbox management software. It's running on those ports. And with that, you can connect to additional settings of the router. So here you can already see also the user configuration. And when you look in the user configuration, you see the yacht router user logo is still there. So it's hard-coded configured also here. And there is a second user, Jere, one of the developer of the company. So he has always a backdoor access to the router. So you cannot change it. With the Winbox management software, you can change it, but then they have no possibility to give you remote support for about that. Yeah, when you are not able to recover a password by using ILSpy for .NET applications, then you can also try to crack the passwords. MKBrutus is one of those projects. Or, as I mentioned, MikroTik router 6.42 or below have a vulnerability. You can use the script here from, and then it will, here is the script. You start it with the IP address and then gives you back the username and the password from the system. So when you found a Winbox management software online, just try those exploit, and maybe it's patched or not. Okay. I contacted the vendor, I informed them, and they promised to fix it, and they did. So, okay. What we need to find those things? Some kind of open source intelligence. So, marinetraffic.com is one very good website where you can look up all those devices. But also, you can also use Shodan. Shodan has also an own ship tracker. So shiptracker.shodan.io is used for VTS, for VZ traffic. So they're only collecting VZ satellite devices with an extra ship tracker website. But I'm using Shodan for a different device. So I have to skip it a little bit. So what the vendor response was, they patched the software. They sent me also a test router module. The .NET application was now obfuscated. So obfuscating, okay, it's not really that hard, but when you obfuscate software, not only obfuscate your Windows software, also use obfuscate then the Android version or the iOS version that they forget. So in the Android version, you still see they have a user and they still have an hard-coded credentials for that. But they're using now SSH. This I can skip. Already mentioned this. Last thing is now Satcom devices. So it's a different story. Very easy when you know how to, but okay. You have offshore internet access. It's quite expensive to use the data plans, but patching is also, you don't do it remotely. Mostly when the ship is in maintenance, once a year or so, then you maybe will patch those satellite systems, but mostly not. So many versions are outside there, vulnerable. And yeah, this already work done by others. So when you use those showdown hints, you will find systems, and then you have to look up if it is patched or not. As I mentioned already, the ship tracker. But what I found was then also by another thing. Okay, this I can show you better in a short, quick demo. I hope I'm connected. I am. Okay, here we are on Showdown. I already typed in the search term. 20 devices are online. I just try here the first one. Hopefully they work. No, the first one was wrong. I have to take this one. Oh no, this is good. So I click on the web page. It makes a redirect, and here we are. So now we have a login screen. So by the way, it's a quite new version, not the newest one. It's a version 179, so the newest version is above 200. So now you have a login screen and no idea how to go on. So what I did was looking for the source code. So and then the interesting things was the JavaScript user login. So when we look at that, it just gives you the JavaScript website, and here's the interesting part. If the login name is dealer, then use the URL menu dealer gx. Okay, let's try. Menu dealer we want to use. Okay, I take now this one. This is the login screen. And we are logged in now. No, we are not logged in, so we opened a web page that the dealer could see. And yeah, it's a little bit slow because it's anywhere on this high C, I don't know. You can see already the name of the ship here, and the signal strength, and here the coordinates, and additional information about the heading and the speed. So here we have now the coordinates where the ship is underway, and so on. Now we can do different things with that. So I stop here. So the last parts in my presentation now. Okay, we looked up it with Showdown. The search string was server.microdigital web server I'm looking for, and then all the devices with these bubble are then the web pages from these devices. So this is in short what is containing in these login script, and yeah, and then you see those web pages for that. So by the way, when you read the manual of the device, you will also find the default credentials, and sometimes they work. Then I looked up under the CVE system if someone already found it, and then, yeah, someone found it already and reported it. And but he reported only for one version, a very old one, but I already can confirm that it is working up to the version up to 200. So the vendor has fixed it. There is a fixed version out there. That's I think also the reason why they are not so much online now again, but there are still some online. Yeah. What else you can do with this thing is you can make firmware uploads, you can change the configuration of the antenna, you can have a command line interface on the ship. So, and this is the part what you need to dig deeper in the system of the ship. Even with the yacht router from Loco Marine, there you have also a possibility to have a command line over the Winbox management thing. There you have also a command line, and from that command line you can go deeper into the system and searching for the other devices, put some netcut stuff on and so on. So that's the way to get on the network of the ship, and then you can explore it more and more. For these CTL devices, what's the risk? Okay, you can increase the cost, or you can make a denial of service by changing the antenna configuration. And the last parts now, the NMEA protocol needs more and more tests about that, so I'm gambling more and more with that. So I have bought some devices to gamble with, so I built up my lab environment for that. The wireless autopilot is also a topic that I'm focusing on when I have time or when I have a ship in available area. And other internet equipment has also been tested by others. So there are so many network routers available, but you need to have time and systems where you can test it. And the worst thing is more and more go into the cloud now. So they're putting also this part we focused on in my presentation here, and they're going now more and more in cloud services that you can have access with your tablet from anywhere in the world over cloud services directly in the engine room. So this makes me a little bit confusing then, because of the cloud service gives you some kind of engine controls. You see information about the engine status, the rudder information, the oil temperature, and so on. So this is then accessible from everywhere, and also all these things has to be looked up. So conclusion about that is so much work has to be done. Some is already started. So in the I don't remember it now. So in the IM cavalry group, so we have a special area for the maritime stuff. So we are grouped there together and working on the maritime stuff. So that's also why I want to thank Hacktivity to having me here, and Brian Satira and Brian Olsen. They gave last week or 2 weeks ago a nice Derbicon talk about ship hacking from a pirate point of view. And they're focusing on propulsion systems and the ICS stuff on the ships. And And may the force be with you. If someone has questions, go ahead, or I think we should do it later outside, because the next presenter is waiting, I think.
Thank you, Stephan.
Thank you.